Okay, today we have a 25-inch Wells Gardner K7000, and this was sent in because it has an issue with blowing the fuse. So if we look at the note here, it says, Mike, thanks for taking a look at my chassis. I tried, learned a lot along the way, but I am leaving it too professional. That remains to be seen. This is the amateur channel. HOT, voltage regulator, and flyback replaced. The chassis will fire off the tube for about 3 seconds, then blow the fuse. Well, you should never run a chassis without having it hooked up to the tube unless you have the horizontal circuit disabled, so that should not be happening. With the HV lead removed from the CRT, which you guys say is a no-no, that's correct. The fuse will still blow. Well, that could be normal operation. The only time I could get the fuse to live is with the flyback removed from the circuit. Tried a different flyback thinking I received a bad component, but still the same result. And his information is blocked out there. So, okay, the first thing I've noticed is that the, let's see here, the G2 connection has a bunch of solder on it, and it's not allowing the connector to seat down on there all the way. It goes into about like that, and that's all it goes down on there, so that's no good. So we have to fix that, but I don't think that's the problem, because that's all that goes on there. It doesn't go down all the way. There's a bunch of solder there from a previous repair attempt, and it's not letting that go on there. But the G2 and focus wires are hooked up correctly. The G2 wire is always the smaller wire. The skinnier wire is always the G2 connection, and the thicker wire is always the focus connection. And they've got that spliced together properly here, so that's not the issue. I'm actually going to try and fix that real quick, because if I don't, I'm gonna forget. So I need to remove all the solder that's on this post. That's all it took for that. Now this should go on here much better, at least all the way down on there. Yes, okay, good. All right, and I'll spread these resistors out a bit. It's not good to have them touching each other. They induce heat onto each other. So, okay, it looks like some caps have been changed, but not all of them. These 3 caps have been changed, but those 4, that one, none of the, it looks like there's only been 3 caps replaced, so it needs a full cap kit. This one, that one, and this one are all new, but these are all factory. I can't quite tell. This one's been changed too, maybe, and that one in there possibly, but all these caps here, these ancillary caps, not the main power ones, have not been replaced, so we'll have to do a full cap kit. Yeah, it is complete, although a little bit dirty. Get you fired up in a hurry. It's about time for my arrival. Ladies, fellas, grab your cups. Alright, R101's been changed out, and it's a little close to the board, but I mean, I guess that's fine. Okay, so initial indications are that it's complete. The fuse is in fact blown. Let's make sure it's actually 2 amps. It should be 2 amps for the 25-inch, and nope, it's 1.5. I don't know if you can see that. Probably not, but it says 1.5 there. So it doesn't really matter. It should be okay. If there's nothing shorted, 1.5 should be fine. So we'll leave that out, and I don't actually have any fuses in stock, but I do have, wherever it went, I can never find it. Every time I set it up here, it disappears on me. Here it is. I do have my little 2 amp circuit breaker, which we can just attach to the leads there when it's time for testing, but okay. Any broken pots from shipping? Nope, those all, oh, yep. Vertical hold is broken. I don't know why it's so difficult to wrap these things properly, but now I got to change this vertical hold pot because it's broken. I think if I was to receive 10 of these 7000s, I'd say probably 6 of them arrive with a broken pot, because nobody ever wraps these properly or protects them. It's broken right there. So, all right, I'll disconnect this to remind myself I got to change that out. Par for the course, but that's not going to cause the fuse to blow. So let's just start going through all the components and seeing what we can figure out. Actually, you know what? Let's look at the bottom first. Maybe there's something obvious. Well, one leg of R89 has not been reflowed, but it's not cracked or broken. R104 seems okay. R101 has been replaced, but it doesn't look like it's in bad shape. Yeah, okay, I don't see anything immediately, so let's just start testing our components. R103, we start with R103 over here. That should be 2.7 ohms. And actually, I'm going to do a little bit more. It's a bit dirty over here. Okay, ohms, and we should have about 2.7 ohms. 2.8, that's fine. R104 should be 15 ohms. If it's anything less than 15 ohms, like 8 ohms or something, then we have a shorted rectifier diode, and we get 15.1, so that's fine. But just for the sake of completeness, we'll check them all. D19, D20, D21, D22, D23, and D24. Yep, so those are fine. Moving on down the line, R101 should be about 5K ohm in circuit. And that's correct. What is that? R97 should be about 270 ohms. I can never remember that one. R89 should be about 3.9, 3.8, close enough. R88 should be 1.8K. There we go, 1.785. R96 should be 1.8K. That's fine. Okay, that pretty much leaves our voltage regulator. And we should get 180 ohms across the resistor here. And we do, so the voltage regulator should be okay. That's the easiest way to check it. But you can also go to diode mode, and on the tall skinny one like this, you go across pins 3 and 4. So 1, 2, 3, and 4. We should get about a 0.15 voltage drop because we're reading through the resistor. If the resistor was disconnected, we'd get our 0.5 voltage drop. So regulator should be okay. We'll check to make sure our C38 width cap isn't shorted. We'll go to continuity, make sure we don't have continuity. And we don't, so the C38 width cap is not shorted. Let's check our HOT. We should get a 0.5 voltage drop from negative on the middle lead to each outer leg here. And HOT is good, so our critical safety cap, we go, this is the same plane, so negative on either leg, and we go diagonal across to these other two, we should get a 0.5 voltage drop. 0.479, 0.475. So that's all good. It's going to be interesting, I think, trying to figure this one out. How about D18? This diode down in here. Let's check D18. That's good. We'll check D13 and D14, which are down over in here. They're not going to cause the fuse to blow, but I'll check them anyway. I believe this one is this way. We should get about 0.3 or so, yeah. And the other one is opposite way. We should get about 0.4. Okay, there we go. So then this one is the other way. Yeah, there we go. Okay, that's fine. All right, we're just checking to make sure they're not shorted is all we're interested in. So I guess what we can do is try Q10 as a last resort. This transistor in here, that can cause problems like this, so we'll just check to make sure it's not shorted. I believe we have to go negative on this lead, no, positive on this lead and negative other two, and it should be 0.5 to each one, or 0.6 and 0.6. Okay, so that's fine. Well, so are we left with... So it only blows the fuse if the flyback is installed. So let's go through and check some traces here. Let's check this trace to here. So this is these two pads here are R89. So if this pad likes to get oxidized and not have good connection, so we'll check here to here. Good, good, and then now down to here. That's good. Okay, so that's fine. Let's check here to here. So that's all okay. And then what about over here? Okay, that's fine. Well, it hasn't been capped, but someone's been messing with, I'm just thinking out loud here, someone's messed with these. There's no connection on pin 5. Is there anything else obvious? Yes. HOT connections, that's good. That's good. That's fine. Flyback traces. Those are fine. Well, that's interesting. Okay, well, it's very possible. It's very possible the person that's using this, they might have a bad yoke that's shorting out their system. However, that wouldn't account for it blowing the fuse on the bench, but they're running the high voltage without a load on it. So that you don't never want to do that. That's very bad. That could cause a problem. Let's check this capacitor back in here, and there's a diode with it. Let's check those and make sure those aren't shorted, because that's been known to happen also. Nope, no short there. And that's fine. So that diode's good and that capacitor is not shorted. So, well, I was hoping this would be something very easy and fast. Well, let's try the light bulb check so we can desolder the collector of the HOT. Oh, you know what? We probably should check our insulator. I wonder if the HOT insulator is the cause of this. So we can disregard that. And make sure that that is not touching anything. So here's our trace. That's the trace. Let's touch the pin. The pin is still... Okay, the pin is not on the circuit anymore. So now we can do our light bulb check. So if we turn this around, we'll zoom out a bit. Let's grab our light bulb. Attach it to the blue wire, which is the regulated side of the regulator. Other lead to ground. And when we plug this in, if our power supply section is good, then the light bulb should light up. If it's not, then we know our problem resides in our power supply section. Okay, breaker's installed. All right, well, here we go. Power supply is fine. And if we go to check our voltage, it should be around 130 volts. We get 129. So our problem is not on our power supply section. Quick and easy test for that. There's also a couple of diodes underneath R97 here. We can check those, and I've never seen these go bad. Those are fine. Well, that's quite the conundrum here. Everything checks good, yet we have a shorting, I'm sorry, a blowing fuse. Sorry, I'm trying to think about what else this could be while I'm trying to talk. I can't talk and think at the same time. I wonder if D10 or 12 is faulty. Nope, 12 is fine. 10 is fine. Well, this is very interesting. I wonder if the insulator is at fault here. We can test that very easily. Neither one of these two, well, I think we probably already checked that. No, it's fine, because the center leg doesn't, we would read a short, I'm pretty sure. Let's solder all this back together. And make sure that's still got continuity. Yep, okay. Well, what do you guys think? Throw a comment down in the bottom. Throw a comment down there. Unless you're watching on your phone, and do it however you can. What do you think is the cause of that? Well, we never really duplicated the discrepancy. Duplicating the discrepancy is pretty much usually always the first thing to do, but I don't want to go through the hassle of going through a fuse, which if I'd had one, obviously I don't, so I'll use this, but I don't know, that horizontal pin looks kind of haggard. Yeah. Well, if they've already changed the flyback twice, it looks like they've got the correct one in there. And it looks like it ran for at least a little while, because it's got dirt on it. None of that's touching or anything. Regulator's good, under load, so it's not a power problem. The HOT, see, the center pin doesn't read to, well, you know what? I'm going to try something here. Let's just inspect this, because I'm out of ideas here. Nothing is reading bad, yet it's shorting a fuse, so I have to suspect that maybe this is an insulator issue. Oh, that's kind of corroded. Oh, well, I found the problem, boys and girls. Look at that insulator's burned a hole right through it right there. And if we look at the chassis, well, a giant burn mark there. If we fold the HOT back, yeah, it's arcing all around that hole right there. So my suspicions have been confirmed. There's a giant arc right there. So yes, bad insulator. When all else fails, look at the how do I phrase this? When all of the normal things don't pan out, go to the abnormal. How about that? Okay, so we're going to have to get a new insulator, clean all that up, because how this happens is you get a burr. There's some type of metal burr on the, if you put a screw through there or something, and there's a burr, it pokes through the insulator into the frame or the back of the HOT and just shorts it out. Look at the screw here. That's just been arcing right there to that screw. And yeah, so there you go, problem solved. So I have another insulator here. We're going to go with a silicone one. That's my last one, actually. My last silicone insulator. We're going to use that one. But I'm going to actually pause here. I'm going to take a couple of pictures here for documentation purposes, and I'll come back and we'll fix it real quick. Hang on. Alright, so I got my pictures taken, and during the interim, I cleaned off all that thermal grease that's in there. I don't even know if it's conductive or not, but take a look at this. Someone's been grinding on this. I'm not sure what they were doing, but it's been arcing right up the top of the hole there, and they've been grinding on it. So I don't know. The HOT is not shorted, but I think what we're going to do here is I'm going to use 2 insulators. I'm going to go ahead and use this one in combination with a new plastic one together. So it might be an issue where someone was using conductive thermal grease as opposed to a burr poking through, but regardless, we're going to do this the right way and not use any thermal grease at all because it's not needed. Wills Gardner used basically no thermal grease, almost nothing. I mean, they used a little bit, but for all intents and purposes, they really used pretty much none. So these have been running for 40 years with no thermal grease at all, pretty much. So it's not needed. I don't recommend it. It's not something you want to, because if you put the wrong stuff on there, it could very well be conductive, and if you don't realize that, then you end up with problems like this. So I don't even bother putting thermal grease on these things, quite honestly. It also helps if you put the nut on the right way. And as you see there, I have a monitor injury there on my knuckle that, unless you actually bleed while you're working on these, are you even really working on them? That's what I say. Okay, and also you don't need to over tighten this. Just kind of go, and that's all you need. You don't need to physically just crank the ever-loving crap out of that screw. So let's make sure it's still good. Back up off a bit and set my meter down. All right, we'll just go to this pad to here, 0.5 and 0.5. Make sure it's not going to ground. And I think that's supposed to be ground. These are tied together. Yeah, so I'll bet you that solves our problem. So I'm not going to do anything else. We've tested everything that needs to be tested. I'm just going to get a tube and hook this up to the tube and try it out. And if it's good, then I'll do a reflow and finish up the rest of the cap kit that someone did a partial cap kit on, and we'll call it good. But yeah, I think that's going to solve our problem. You know, fingers crossed. But we'll have to. It'll remain to be seen. I'm going to take this thing and throw it right in the garbage. Put my deal insulators back, and we're going to have to replace. Oh, I forgot. We got to replace this V hold pot. I have a whole bunch of kits for this very reason, because nobody ever protects these remote boards and all the pots get broken. And let's see, for vertical hold, let's go ahead and just take this one out of here. So yeah, the leg is broken off of there. So for vertical hold, we're going to have to see what that is. Vertical hold is I got a bunch of spare ones too here, but vertical hold is 500K. What's this one down in here? $500K. Well, let's go a probe in here. Okay, so 500 ohms, so that's no good. Come on. 27K. 500 ohms. 28K, 10K, 200 ohms. That's the, I think the 200 ohms is the brightness pot. I think it's 200K though, I don't know. 500 ohms. Wait a minute. $3K, what the hell? Well, that's 500K right there, isn't it? Yeah, 548K. Huh, okay. Well, there we go. All right. Let's put these back. That said 500 mega ohm, and that, or 0.5 mega ohm, and that threw me for a loop. I'm like, wait a minute, that should be 500K right there. So, all right. Well, that shorted insulator there, or that bad insulator, was shorting the HOT straight to ground, the output right to ground. That's why the fuse was blowing. But that would certainly do it. Okay, and I'll put this about middle, and we'll solder this in. And that's done. Okay. The rest of these definitely are intact, he says, with all the confidence in the world. Alright, let's plug it in. Alright, so now let's get a picture tube, get this hooked up, and see what it does. Alright, so we're all hooked up here on a dedicated K7000 tube. We got our anode, neck, yoke, ground, power, video, and remote. And I got my circuit breaker installed because I don't have any fuses. They'll actually be here tomorrow. So this insulator issue has to be the problem. There's nothing else that would logically cause this. We've checked everything that could cause this, and the only issue we found was that insulator issue. So let's turn it on, cross our fingers. I do have my Mortal Kombat 2 PCB here that we use for testing because it's just easier than using the TPG with the bench setup here. So, okay, fingers crossed. 1, 2, 3. Yep. And as expected, our vertical hold needs adjusted. Oh man, let's get the tripod set up and do some adjustments here. All right. You see it all right? Yeah, that's not bad. Okay. Brightness all the way down. Contrast all the way down. Screen pot up until we get raster lines. I'm not getting raster lines, but we'll turn it to about a quarter turn up. Black level. Okay. Back down. So black level up until the background is not black anymore, and then back down until it just is black, which is roughly there. Contrast up. Now we got to turn our, well, now all these color pots need adjusted. Let's start with our focus, actually. Okay, there's good focus. We are missing, are we missing red? We're missing a color here. Oh no, red's just too high. Yeah, we're missing red. Yeah, red is non-existent. Oh, bad solder joint on the video input header pins. That's part of the reflow. I obviously haven't done that yet. But we have a bad solder joint on the red. Can I bend it enough? Okay, there we go. Good. There we go. That looks more like it. All right. Again, we'll go into the menu here so we can adjust our size and position, monitor patterns, crosshatch pattern. Okay, we're way too wide. We can fix that quite easily. H position, roughly there. vertical position works, vertical size, that's good. We need to adjust our 50-60 Hertz pot. Vertical position, we'll do that. Vertical size, we want, that looks pretty good there. 50-60 Hertz pot just ever so slightly because the top is taller than the bottom. So 50-60 Hertz pot just a little bit. That's better. Okay. Now we adjust our position. We want to see a little bit of red. And we're pretty jumpy here. Yeah, that's a little bit better. Okay, so let's adjust our horizontal width. Make sure at least we can do that. And I'm going to have to turn this slightly and get my adjustment tool in there, which is never fun. There we go. Can we adjust our... Oh yeah, okay. We want to move this in until we see just a little bit of red. Right there is equidistant for the green. That's about all we get, but I think that's fine. Little position, okay. What do you think? I think that's pretty good. I'll live with that. But the background's a little too blue. And we'll turn our brightness down ever so slightly because the background's not black. There we go. Okay. Oh, we're way too green. Holy crap. Just gotta adjust stuff. You know, this is not for this picture tube. But let's turn up our red slightly. Oh, did we lose red again? Oh, we lost red again. Come on. Obviously, like I say, I'll take care of that during the reflow, but... Oh, now I lost my sync wire. Jeez. There we go. Okay, stay there, red. Come on. Yeah, have to play around with the colors, but regardless, it's working. So yeah, that was the problem, that bad insulator, taking the HOT to ground and causing the fuse to blow. So I'm going to put all the color pots in the middle here. Okay, that's not bad. Let's turn up green a little bit. And then turn our contrast down because we're bleeding. Alright, I gotta say, that's not bad there. So, alright, well, there you go. Quick and easy. Hopefully you learned something. Like I say every time, make sure you like, share, and subscribe. Comment down below what you thought. And we have another resurrected K7000. So I'm going to go through and do the full rework and the full reflow and fix the cap kit, or finish the cap kit like it should have been. All the normal stuff I redo with these, I'll go through and do all that. But otherwise, yeah, that's it. So again, appreciate it. Make sure you stay tuned for more, and we'll see you next time.